Now that you have learned multi-views, whether it's 1 view, 2 views, 3 views, 6 views, auxiliary views, section views, and you have learned isometrics, now we need to apply those to pipe drawings. So in this illustration, I am going to show you how to draw a single view, double line and single line pipe drawing. And I will also show you a multi-view of pipes as well. So as you can see here, I just have an illustration of a regular pipeline that has different fittings. Has a cap here at the end, a Y which is a lateral here, gate valve, union, cross, globe valve, and all different types of fittings. So just to generate a single view of that double-lined drawing, it would look like this. Notice that some of the fittings, like the valves here, have been replaced by their symbols. If I zoom in, you will notice that I have valves symbols here, and there. This is a regular gate valve, a globe valve, and then the check valve. Also, I have a reducer and some different types of fittings around the pipe setting. If I was to include the center line for that, these pink or magenta lines represent the center lines. Oh, by the way, at the end of this pipe right here, we have a pipe that continues on. That's like a cross section, which means the object has been imaginarily cut right there. And so this little symbol here, like a little yin-yang kind of looking symbol, is what we'll look at here. When you have a piece of pipe, this is an elbow that is going away from the viewer, then this is how it will be displayed in the double line drawing. Now, to generate this type of drawing, it took me a little bit of time, even if I had these preset blocks for different pipe fittings. It takes a little bit of time just to generate something like this. And so what we end up doing is generating a single line pipe drawing instead that will be more simplified, but then that means that the reader has to have a little bit more training to decipher what the drawing looks like. And so to be able to generate something like that, what we do is we turn the center lines here into visible lines. After that, we get rid of these double pipelines like so, and now we only have our fittings exposed. After that, we change each one of these fittings for their symbols, cut through some of these lines that cross some of our valves and other fittings. So I drew it down here so that we can see it a little better, and you will see that all of these fittings have been replaced by their individual symbols. Now, 1-view single line pipe drawings are useful when we have a setting that is very simple and that it doesn't have very many lines that are displaying the depth. In other words, you don't have pipelines that go away from us or come towards us, because then you wouldn't be able to determine what the depth of that would be. So when that happens, we have to generate multi-view drawings. To explain how a multi-view double line drawing looks like, I want to show you the drawings for individual fittings. In this case, we have a 90-degree elbow. And here you will see that we take the side of the elbow as the front view. Now I want to display that with the center lines. Now in here we have the front view. This is the right side view. Notice that we have the rounded shape over here for the roundness of the elbow on top, and then these hidden lines represent just the hidden circular shape for the end of the pipe fitting here. To the left side, that is an opening that we would see inside, and so we have 3 different methods to display pipes in which we're looking at the hole itself, and that is including section lines like this, or a yin-yang symbol, or just a dot in front of it. That just lets the reader know that you're looking inside the pipe. Notice that we do not draw the hidden lines for the interior wall for each one of our pipe fittings, and that's because it would clutter the drawing and would not serve a purpose. Notice that the top view here resembles the side view, and this side here with the bottom of the fitting here exposed, then we would have section lines there. If I was to draw the single line drawing for that, this is what it would look like. We have taken the exterior lines here for the pipes, okay, and we have left just the single line here and there, and this shape would be replacing the center line. Okay, so the right side view would look like this. Notice that there's a break in the circle here, and that would be representing where the circular shape has hidden lines there. On this side, we would have the circular hole that is displaying inside of a pipe. Therefore, we would have one of these three symbols there. This line stops at the end of the circular shape here, and that's because we see the circular shape before we see that line going all the way to the center. And then this would represent the end of the fitting on the other side. Just look at the top view. Notice that this line stops at the center point of the circle because this section of the pipe is seen before the circular shape at the bottom. And then you can look at the bottom view. Okay, so that is the drawing for a 90-degree elbow. Let's look at the double line drawing for a 45-degree L or elbow. It's the same thing. Notice now that the circular shape that we had previously drawn for the 90-degree here has become an elliptical shape or an oval shape just because the end of the pipe fitting here sits at an angle. When that angle is projected to the right side view or the left side view, it projects as an oval shape. So when we generate the single line, it would look like this. Okay, again, we have erased the outer shell. We have changed the center line to a visible line, and we have either created gaps or created section lines relative to the position of the pipe. If we're looking inside the pipe, then we draw section lines, yin-yang, or a dot. And if we don't, then that would create a break, and the break will be where the normal hidden lines would be for that oval shape on the right side view here. The top view and the bottom view seem like they're not displaying a whole lot just because of the angle of the pipe itself. But notice from the bottom view, we would see this exposed, so that's why this has a section lines here. And the top view here would also have section lines here. From view to view, notice that my section lines go opposite ways. That's just how my system drew them. But because they're different views, then it's okay to have the lines going separate or different directions. Okay, now I want to show you the same pipe fitting, but this time it has a piece of straight pipe added to the multi-view. I find that one of the most difficult things to do is to figure out which side of oval shapes or circular shapes need to have a gap and which ones don't. What line needs to go to the middle or the center point of ovals or circles and which ones don't. And so you would have to look at the adjacent view to determine that. For example, this is the right side view, this is the front view. The right side view is looking from the right of the object. From here, if I was standing right here looking at this, I would see this visible and this side visible. So when that projects up, that's the visible part, so there's no break there. And in here, that's the visible part, and there's no break here. This line will go to the center of that, it projects from there, and from there you draw it down. And the same thing happened here. This intersection here projects there, and that line goes down from there until it meets the top of the next end of the pipe fitting here. So that's how you determine that. Now on the left hand side, notice that the one side of the pipe fitting that is visible is the bottom. So that one is left untouched. So that means that the other side will have the gap. See, because you would see this line before you saw the end of the pipe behind it. And so that would be the hidden part, and there's where the gap would be. It continues on till you meet here, which this would be open, so that means that you have section lines here. Same goes with here. This is the top view, the adjacent view is here. There's no other pipe fitting or anything like that here, so we would see the end of this pipe exposed, so you will have the section lines there. The end here, this side of that elliptical shape is the one that is solid, so it goes all the way through, and this side, because this line would be hiding the bottom side there, then that's where the little gap in the oval would be. After that, you would see just part of the circular shape for the other end of this 45-degree L pipe fitting. Now, in this case here, this end of pipe is represented by the oval shape. Again, the part that would be visible is this side, and this side would be hidden by the straight line from the pipe, and so that's why that line starts at the center and then goes all the way to this point. This is the oval that is representing the end of that pipe there, okay, that is hidden behind the circular shape that has the section lines, because that pipe is open now to us. Let me show you one more fitting, just a single line this time. This is for a T. Left side and right side look identical because, again, the T, the placement of the T and how it is. Section lines here because those are ends of pipes that are exposed. But I want you to pay attention to the top view. You would have a circular shape where that is, but you would have a gap here and there because the straight part of that fitting is the one that is visible, and the circular shape, which is at the bottom, would have the gaps here to represent that hidden section. In this case, is the opposite. We are looking at the insides of the pipe from the bottom, so that would be open here, but at the ends you would have the straight lines just like the front view.